Hi everyone, in this video we're gonna get the introduction to the cosine curve. We're gonna start with the basic function, which is y equals cosine of x, and then we move on to an example which is actually a variation of this function, the variation type 1. So the variation will be something of the form y equals a times cosine of x, where a is not necessarily 1. We know that cosine and sine functions are cofunctions. Therefore, we have that cosine of x is the sine of pi over 2 minus x. Because of this, we have that the cosine curve is the sine curve but shifted by pi over 2 radians. In order to graph the cosine function, we take the same steps as for the sine function. To graph the cosine function, we're gonna be using quadrantal angles and also the unit circle to find points on the terminal side of the quadrantal angles. As before, in the unit circle, we have 4 points that we're gonna be considering in order to find cosine functions. Recall that for the unit circle points, as points on the terminal side of the quadrantal angles, the first coordinate of the points correspond to the cosine function. And again, because cosine function is defined as the x coordinate of the point divided by r, but for the unit circle r is 1, what we needed to do is to look at the first coordinate of the point in order to find the cosine function for the quadrantal angles. So if we consider the angle 0 degrees or 0 radians, we have that the cosine of 0 is 1, because we're talking about this point on the terminal side, which is the point 1, 0, and because the first coordinate of the point is 1, we have the cosine of 0 is 1. For the quadrantal angle pi over 2, which is the same as 90 degrees, we have that the point on the terminal side corresponds to 0, comma, negative 1. So 0 is the cosine of pi over 2, and we have that also expressed here. So if we are considering the angle pi radians, which is 180 degrees, the point on the terminal side corresponding to that angle is the point negative 1, comma, 0. So the cosine of pi is negative 1. The next quadrantal angle is 3 pi over 2, which is the same as 270 degrees. The point on the terminal side is the point 0, comma, negative 1. Therefore, the cosine of 3 pi over 2 is 0. Moving on to the angle 2 pi radians, which is equivalent to 360 degrees, we have that the point on the terminal side corresponds to the point 1, 0. Therefore, the cosine of 2 pi is 1. So with this evaluation, we have the following points which we plot in order to get the cosine curve. So the red curve you see here is actually corresponding to the cosine curve. And notice that there is a shift of pi over 2 of the sine function, which is expressed with the blue curve. Because the sine and cosine are cofunctions, they have similar properties. So for the basic function y equals cosine of x, we have that the amplitude is equals to 1. That corresponds to the coefficient of 1 in front of cosine of x. We also have that the period of this function is the same as the period of the sine function, corresponding to 2 pi. Okay, so for this one, notice that we have the function y equals negative 2 cosine. So for this variation, making the number in front of the cosine function with 1 inside of x. So that's the variation you have right now. So this gives you your amplitude anyway. So for this example, the amplitude is equals to the absolute value of the number a, which is negative 2. So the absolute value is positive 2. Why we take the absolute values? Because again, amplitude is a distance. So distance would never be negative, even though that number is negative. we actually consider the absolute value, which is always going to be positive. Now, the period of the basic function is the same as before. Because there is a 1 in front of x, so the period runs as 2 pi, like the same for sine. And the quantity that I use for the 5 key points is the same. So I take period of the function and divide it by 4. So that is 2 pi over 4. You can see it's the same computation. So the quantity, again, is going to be pi over 2. So I use this quantity to move from one angle to the other angle. Right now, it's look like the same. But again, for the next variation, you're going to see that in front of x is not going to be 1. And the period of the function will change, and these quantities will change. What's not going to change is the 4 points from the unit circle that you're going to use based on this angle. Okay, so again, how you start? You always start from 0, and then from 0 you add quantity, so you get the same result. And then take now the current one, which is pi over 2, add the quantity again. So this is 2 pi over 2, which is pi. The next one is from pi, add the quantity, and then you get 3 pi over 2. And finally, the last one here for this particular function, you have right now 3 pi over 2, and add the quantity, pi over 2, so you get 4 pi over 2, which is 2 pi. So again, it's going to be the 5 values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And using the unit circle, so let me squeeze the unit circle down here. Cosine function depends on the x value of the points on the terminal side. So the x value for 0 radians is 1. So meaning cosine of 0 radians is 1. So my y value right here is -2 times the cosine of 0. So this is -2 times 1, because cosine of 0 radians from the point on the unit circle. So this computation is -2, right? Because -2 times 1. So the point is the angle 0 and the y value, which is -2. So I have 0, -2. And then next angle is pi over 2. So pi over 2 is next. So the terminal of pi over 2, which is 90 degrees, this. So the cosine of pi over 2 is 0, the first coordinate. So y value here is going to be -2 times cosine of pi over 2. So this is -2 times 0, which is 0. So the result is pi over 2, 0. All right, the next angle is pi. The terminal side of pi is this guy. This is 180 degrees, so this is the terminal side. I'm going to look at the first coordinate for cosine, and that's -1. So cosine of pi is -1. So my y value for the function is -2 times the cosine of pi. So I have -2 times -1, which is +2. So the point is going to be the angle pi comma +2, right? -2 times -1, +2. The next angle, 3 pi over 2. Now, the terminal side is down here. Cosine of 3 pi over 2 is 0. So in my computations here, I have y equals -2 sine of 3 pi over 2. So the result is -2 times 0 from the unit circle. So this result is 0. So the point for the graph is 3 pi over 2, 0. And finally, the last one, which is 2 pi. So we back to the beginning, where it's the same as 0. So cosine is the first coordinate of that point, which is 1. So I have that the y value of the function is -2 times cosine of 2 pi. So this is -2 times 1. So this is -2. So the angle 2 pi has a coordinate of -2. And again, the oscillation is happening. So -2, 0, +2, 0, -2. So if I were to continue, this start to repeat again and again and again. All we need to do now is to put the values in the graph. So we have 0, pi over 2, pi, 3 pi over 2, 2 pi. Now for 0 radians, the value of x for the graph, you have negative 2. So let's say negative 2, 1 is somewhere right here. This is negative 2, which means the positive 2 is this value right here. So 0, negative 2 is the first point. 0, negative 2. And then I have pi over 2, 0. And then I have pi with 2. And then I have 3 pi over 2, 0. And then I have 2 pi with negative 2. Okay? So the smooth curve is something that looks like this. So notice slightly different the graph, but still an oscillation. And it's upside down, the oscillation, because we have a negative 2 as a value of A in front, right? So this is negative 2, and it's kind of flip upside down. If you look at the basic function, it's flipped upside down because of the negative line. So again, it's the same for sine. The only difference that when you do cosine, for the unit circle, you're looking at the values of x for the point. So the values of x from the point indicate cosine. Okay? Sine is the other value, which is this. So this is sine. I'm going to stop here. Next class, we're going to cover the other variations. I'll go over and over again about the 5 key points. You're going to see a difference in the period of the trigonometric function as well. But you kind of have the idea right now. So please start to do the homework online.